So in this video, we're going to talk about how to use regressions to make decisions in DESMOS. So in this example, it says the company has tracked its annual profit for the last 8 years. Each year, the company hired 50 new full-time workers to increase the number of units it manufactures. Use the table of values to find a quadratic function to model the data, then determine whether the company should hire 50 new workers in 2017. So what I'm going to do is I'm going to turn these years into the number of years since 2009. So we're going to use 2009 as our frame of reference, and then I'm going to turn all these values into how many years it's been since 2009. So this first, 2009, obviously it's going to be 0. 2010 is 1 year after 2009. 2011 is 2 years. 2012 is 3 years. 2013 is 4 years. 2014 is 5. 2015 is 6. And 2016 is 7. So I'm going to use all of those values as my X, and then for Y, I'm going to do the profit in millions. So I'm going to click the plus sign in the upper left-hand corner and click Table. I'm going to enter all these values here. And then in Y, I'm going to enter the profits. 3.5, 4, 4.5, 4.7, and 4.76. Okay, so now in the second row, I'm going to tell it to approximate a quadratic. So I'm going to say y1 is approximately ax1 squared, and then plus bx1 plus c. Okay, so now you can see it's given me my quadratic function, and I can write the equation. It's going to be y equals, and I'm going to round to the nearest thousandth, so I have negative 0.074 x squared plus 1.057x, and then plus 0.999. Okay, so now it says to determine whether the company should hire 50 new workers in 2017. 2017 is 8 years after 2009, so that's going to be x equals 8. So I have y equals negative 0.074 times 8 squared plus 1.057 times 8 plus 0.999. Okay, so now we're going to go to our calculator, and then we're going to type in negative 0.074 times 8 squared plus 1.057 times 8 and then plus 0.999. And then when we hit enter, it tells us 4.719. Well, notice that this 4.719 is less than the profit in 2016, right? So we're going to say no, they should not hire more workers, because remember what a quadratic will do is it'll go up until a certain point and then it starts falling back down. So what it means is beyond this 2016, what's going to happen is if they keep hiring 50 new full-time workers, their profit is actually going to go down. And if we think about it, it kind of makes sense, because the more workers they hire, the more they'll have to pay them. So it's only going to keep, increasing their profits up to a certain point, and then their profits are going to decrease. Okay, so in this example, it says that 2 kids run a summer lemonade stand. They're hoping to earn $100 each to give to the children's hospital. Their total profit for the first 7 days is given in the table below. Find a linear model to fit the data. So let's go ahead and enter this in DESMOS and create our linear model. So we entered our X values, and then the profit is going to go into Y. So 6.2. And when you're doing these, just double check and make sure that you enter the values incorrectly. It's very easy to sometimes make a mistake when you're entering in your table. So always just go back and double check. So now we're going to tell it to approximate a linear function. So y1 is approximately mx1 plus b, and there is our linear model now. So let's go ahead and grab that equation. So we have y equals 1.961 x plus 2.186. Okay, so there's our linear model. It says how many days will they have to run the stand before they both earn enough to give to the children's hospital? Well, let's look at it. There's 2 kids and they want to earn $100 each. So that means that they actually want to earn a total of $200. Right? So we want to figure out when this function is going to be equal to 200. So we can say 200 equals 1.961x plus 2.186. And we can just solve this like we would solve any other linear equation, right? We can just subtract 2.186 from both sides. And so on the left side, we'd have 200, let's see, 200 minus 2.186. And that's going to give us 197.814 equals, and then on the right side, all we have left is 1.961x. And then we can divide both sides by 1.961 to solve for x. And so when we do that, we get our answer, which is 100.8. Okay, so since we're talking about days, we're going to say that they have to run their lemonade stand for 101 days before they both earn $100 to give to the Children's Hospital. Okay, so in this problem, it says a biologist has been studying a population of wild rabbits in a park. The biologist noticed that the population is increasing at an exponential rate each month. A team of vets has agreed to participate in a catch, spay, neuter, and release program when the population goes above 750 rabbits. Find an exponential function to model the population of rabbits in the field. So let's go ahead and clear this out and now create our exponential function. So for months, we have 1, 2, 3, 4, 5. And then we have the number of rabbits, which is 30, 50, 70, 100, and 152. So in row 2, we're going to tell it to approximate an exponential model. So y1 is approximately a times b to the x1. So here is now our exponential model. So let's go ahead and write our equation. So we have y equals 21.626 times 1.475 to the x. So now it wants you to use this model to predict when they should start catching the rabbits to spay or neuter them. So they're going to start catching when it goes above 750. So we want to figure out when this model is going to equal 750 rabbits. So that will require us to solve this exponential equation. So we have 750 equals 21.626 times 1.475 to the x. So remember, to start off, we're going to isolate that exponential term. Okay, so we're going to divide both sides by 21.626. And so on the left side, that's going to give us 750 divided by 21.626, which is 34.680. And that equals 1.475 to the x. Okay, so now what we can do to solve is we can take the log or the ln of both sides to get this x out of the exponent. So I'm going to just do log. So we have log of 34.68 equals a log of 1.475 to the x. And what I can do now is use the power rule to bring this x down here. So I have the log of 34.68 equals x log 1.475. Now to solve for x, I can divide both sides by the log of 1.475. And when I do that, I have x equals, and then let's do this on the calculator. So we have log of 34.68 divided by the log of 1.475. And then when we hit enter, that tells us 9.124. So approximately 9 months is required for the rabbit population to equal 750. Okay, so that's how you can use linear, quadratic, and exponential models on DESMOS to represent data and make some informed decisions.